All right, guys, for this problem, it says a spherical balloon is being filled with a gas in such a way that when the radius is 2 feet, so when r is 2, the radius is increasing at a rate of 1/6 feet per minute. So the derivative of r with respect to t is 1/6, and I'll put feet per minute. So that's the rate of change of the radius, and the radius at that moment or that instant is 2 feet. All right, the question is asking how fast is the volume changing? So it's asking you to find dV over dt, or the derivative of the volume with respect to time. So notice it does give us the formula for the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. So I want to take the implicit derivative of the following formula with respect to time. So I'm going to take the derivative with respect to time of v equals the derivative with respect to time of 4/3 pi r cubed. Notice that the variables do not match, so the derivative with respect to time of v would be dv over dt. And then I notice that 4/3 pi is a constant, so I can take that out. And now the derivative with respect to time of r cubed, well, the derivative of r cubed would be 3r squared. So dv over dt equals 4/3 pi 3r squared. But since the variables do not match, I'm going to have dr over dt. All right, notice that I have 4/3 and then this 3, so the 4/3 and the 3, I could multiply the 4 times 3 and get 12 and then divide by 3 and end up getting 4 again, but I'm just going to simply cross out those values, and so that'll leave me dv over dt equals 4 pi r squared dr over dt, and so now I'm just going to substitute some values in here to get my final answer. I'm going to have 4 pi r, in this case, was 2 squared, and then dr over dt was 1/6. 2 squared is 4, so this value is 4. 4 times 4 is 16, so that's going to give me 16 pi over 6, and then that reduces, I can divide by 2, and then that'll give me 8 pi over 3. And so this is volume, so this is feet cubed per minute. So in other words, at this instant, the volume of that spherical balloon is increasing because it's positive at a rate of 8 pi over 3 cubic feet per minute. If you wanted to actually work that out, 8 times pi divided by 3, it's roughly 8.38. So I'll put that. It's roughly 8.38 cubic feet per minute, which would be an approximate answer, and then this would be the exact answer.